Now let me do some examples to show you that how we're going to use the chain rule. Example number 1. If f of x equals to x plus 1 to the whole square, this is my outer function, and x plus 1 is the inner function. We have already discussed that we have one outer function and one inner function. So in x plus 1 to the whole square, the square is the outer function, and x plus 1 is the inner function. So what we're going to do here, we're going to take the derivative of the outer function first, and then times the derivative of the inner function. Look, this is my g function, which is the outermost function, and x plus 1 is h of x, it is the inner function. So its derivative will be 2 into x plus 1 to the 2 minus 1, which is according to the power rule. F prime of x equals to n times x to the n minus 1. My n is 2 here. This 2 will come here in front, n, and then subtract 1 from n. N is 2 here, so 2 minus 1. This is the derivative of the outermost function, which is g. So the derivative of the outermost function, which is 2, is this. And then to take the derivative of the inner function, which is x plus 1. X plus 1 is my h of x, it is the inner function. So times the derivative of x plus 1, which is 1 plus 0. Look, what we do in the chain rule, if the given function f of x equals to x plus 1 to the whole square, the square is the outermost function, which is g, and x plus 1 is the inner function, which is h of x. First we're going to take the derivative of the outermost function. So this green thingy is the outermost function. If you take its derivative, x plus 1 to the whole square, derivative of x plus 1 to the whole square, it will become 2 into x plus 1 to the 2 minus 1. Just simply apply the power rule. Now once you did with the outermost function g, then you have to take the product of the derivative of the inner function. The inner function is x plus 1. Its derivative will be 1 plus 0. Take its product. Derivative of x is 1, and derivative of 1 is 0. Derivative of any constant number is 0. That's what we do in the chain rule. First take the derivative of the outermost function, and then times the derivative of the inner function here. Now do simplification. At the end you will get 2 into x plus 1. This 2 into x plus 1 is the final derivative of x plus 1 to the whole square. This is the derivative of x plus 1 to the whole square by using the chain rule. But what if we solve the same equation by opening the parentheses? If I just apply a plus b to the whole square formula here and open the parentheses, what will be my answer? Let me apply another method here. Since I have square here, so I will write x plus 1 into x plus 1. I have square here. I can write x plus 1 two times, x plus 1 into x plus 1. If it is 3, we have to write 3 times x plus 1 into x plus 1 into x plus 1, and so on. Now I'm going to take the product of x plus 1 with the x plus 1. So I will have f of x equals to x squared plus 2x plus 1. Now to apply the power rule, just apply the power rule. So f prime of x will be 2x plus 2 plus 0. According to the power rule, if you remember, x squared equals to 2x, and 2x equals to 2, and derivative of 1 is 0 because it is a constant number. So f prime of x equals to 2x plus 2 plus 0. I'm going to take 2 common from here, and from here, to have 2 into x plus 1. So I got the same answer, 2 into x plus 1, as I got last time by using the chain rule. By using the chain rule, I got the same 2 into x plus 1 answer. And so is here, 2 into x plus 1. I got the same answer with 2 alternate ways. What if I take again the same example and using the substitution method? Let me take the same example, y equals to x plus 1 to the whole square. This time I'm going to use the substitution method to find the answer. I'm not going to open the parentheses. Let me do substitution method. I have the same function x plus 1 to the whole square. This time I have y instead of f of x. So whether you put f of x or y, f of x equals to y, it is one thing. For the substitution method, take x plus 1 equals to u. Let u equals to x plus 1. Just let x plus 1 equals to u. And then take derivative on both the sides. So I will have du over dx equals to 1. Take derivative on both the sides. On the left side, it will be du over dx. derivative of u will be du of dx. On the other side, derivative of x plus 1 will 1, because derivative of x is 1 and derivative of 1 is 0. So 1 plus 0 is 1. Since I let x plus 1 equals to u, therefore I will have y equals to u to the whole square. Because I let x plus 1 equals to u, so just put u for x plus 1 here. This thing will become y equals to u to the whole square. Put x plus 1 equals to u. Since my independent variable is u, so I'm gonna take derivative of y with respect to u. By taking derivative of y equals to u to the whole square, I will have dy of du equals to 2u. Because my independent variable is u, there is no more x here. So I'm gonna take derivative of y with respect to u, not with respect to x. It will be dy of du, and derivative of u squared is 2u, because 2 times u to the 2 minus 1 will be 2u. Its derivative will be dy of dx, remember. Why dy of dx? Because look, I'm going to differentiate y with respect to x. Last time I had u, so I differentiated it with respect to u. It actually equals to dy of du, because look, derivative of this expression will be dy of dx. Because I have x here, it will be differentiated with respect to x. It actually equals to dy of du after applying the substitution method. This thing equals to dy of du, and then times du of dx, which is here, du of dx. Look, I want to repeat it again. I took the same example number 1, but this time I'm going to use the substitution method. So I let x plus 1 equals to u, and then took derivative on both the sides to have du of dx equals to 1. So y equals to x plus 1 to the whole square will become y equals to u to the whole square, because x plus 1 equals to u. So derivative of this expression will be dy of du equals to 2u. It will be differentiated with respect to u, not with respect to x. Independent variable is u here, not x. Similarly, when I take the derivative of this expression, it will be dy of dx. dy of dx, because look, it is with respect to x, not with respect to u. So, but it actually equals to dy of du times du of dx. After taking the substitution method, this thing equals to dy of du times the derivative of the inner function. This was the outer function too. And then times the derivative of the inner function, which is du of dx. du of dx. Differentiation of u with respect to x. How we know that it equals to dy of dx? Because look, you can simply cancel du with the du, and at the end you will get the same dy of dx. So you got the same dy of dx here. Therefore, dy of dx equals to 2 into x plus 1 times 1. Remember, it is the derivative of x plus 1 to the whole square. By applying the chain rule, it equals to 2 into x plus 1 times 1. This 2 into x plus 1 is dy of du, where I let u equals to x plus 1. And then times 1, du of dx equals to 1. So there I got the same output when I use the substitution method. It is 1, so 1 times 1 is the same thing. So I got the same answer, 2 into x plus 1. We can use different methods to get the same answer, but chain rule is the simplest one. When you compare this method with the regular chain rule method, it is much easier and straightforward compared to the other methods. Therefore, I'm going to use this method all the way.